Podstar.
On a densely populated coastline with seaside homes, hotels, beach resorts overlooking the water, and a harbor filled with boats, a powerful storm is approaching. Waves are rising. Sea level is already higher than usual. Local authorities must decide whether to reinforce coastal defenses, evacuate neighborhoods, or close key infrastructures. After a few hours, here's the decision: evacuate the population. Unfortunately, it's too late. Streets are flooded and so are houses. Cars barely move through traffic and their tires are slowly sinking. Half the community is stuck at home and the other half is in the street, potentially exposed. Stop it, someone says. The storm suddenly freezes, and cars and streets disappear. What I just told you never happened. That was a simulation run in the digital twin of the ocean platform. The digital twin of the ocean is neither a video game nor a magic tool, but a real technology whose role in our lives will be discussed in today's episode. So, get ready to join both real and virtual worlds and ponder the question: what if? My name is Federica Orsi, and this is Green Tides, a podcast by the Decade Collaborative Center for Coastal Resilience, about people, science, and ideas that are shaping the future of our coasts. What if we could test scenarios before storms hit? What if coastal managers could explore different choices and see their consequences before making them real? The what-ifs are just the first step in understanding the importance of the digital twin of the ocean. For decades, ocean science focused on observations, measuring temperature, tracking currents, and recording sea level. These observations remain fundamental, but today they are no longer enough. Climate change is accelerating. Coastal risks are increasing. Decisions must be taken faster and with big uncertainty. To face this challenge, science must evolve, from describing what is happening to helping societies anticipate what may happen. So, here comes the digital twin of the ocean. A digital twin of the ocean is a virtual replica of the real ocean, continuously updated with data from satellite, coastal sensors, numerical models, and artificial intelligence. In other words, it is not a static map. It is a dynamic system that evolves as the ocean evolves. It allows scientists to simulate scenarios, test responses, and explore future pathways. In simple terms, helps to ask, what if? And see the possible answers. To understand how this works in practice and how close we already are to this future, we spoke with one of the scientists leading this frontier.
My name is Giovanni Coppini. I'm principal scientist at CMCC, and I'm director of the strategic program Global Coast as a New Frontier.
As Giovanni said, he works at CMCC, Euro-Mediterranean Center for Climate Change, an international research foundation dedicated to studying climate change and its impact, with a strong focus on coastal and marine ecosystems. CMCC is one of the strategic partners of the DCC-CR within the UN Ocean Decade, working side by side to transform climate and ocean science into tools that support real-world decisions.
The digital twin of the ocean are relevant for coastal risk management because the coast is where the climate risk become more real for people, is where sea level, storm surge, erosion, marine heat waves, pollution, flooding from rivers, and impacts on ports, tourism, ecosystem, and so far so on, really meet in the same place. And it is the context where traditional observation and models alone are no longer enough. We need new system that helps to understand not only what is happening now, but what could be happening in the next future and how to manage it. So that's why the digital twin of the ocean are so relevant. The digital twin of the ocean are connecting observation, models, computing, and increasingly artificial intelligence into one operational system. In practice, the digital twin of the ocean helps to move from a coastal management in a reactive manner and with a reactive approach to an anticipatory one.
In his daily work, Giovanni has to analyze different kinds of data and models and understand which are needed for a truly operational digital twin. Let's see which models and data he uses.
Well, a digital twin comes to be truly operational when you combine three elements and you make them working together continuously. The first one is observation, the second are models, and then you need a computing cloud and HPC, so high-performance computing infrastructure behind to make it functioning. So first, the observation. So you need to have available satellite, tide gauge, which measures sea level in the coastal area, wave buoys, coastal radars measuring currents and wave, and then the weather information and all the in-situ measurements related to currents, temperature, salinity, sea level, and water quality. So without real data, you risk the digital twin get disconnected from real reality. The second are models. And in addition to the classical models, especially today, we use models that are suitable for the coastal environment. The third is the operational layer. So we need to integrate this data. Now we are doing it more and more on the cloud to make everything accessible and fast. But we also use a lot of high-performance computing. So when you have all these pieces together, so as you see, it's quite complex, then you have a digital twin that becomes efficient, becomes accessible, and is not only a scientific exercise, but is a practical support system for decision of the coastal.
But building a digital twin is not only about scientific models. Behind every simulation, there is a complex digital infrastructure, data pipelines, high-performance computing systems, secure platform, and coastal monitoring. To understand this invisible layer, we spoke with Megi Hoxhaj.
My name is Megi Hoxhaj. I am a telecommunication engineer and I am the leader of the research unit Operational Forecasting System and Decision Support System in CMCC.
Megi can also tell us something crucial about digital twin. What needs to happen behind the scenes to make this simulation reliable and constantly updated.
When people think about a digital twin, they often focus on the simulation itself. But what really makes it reliable is everything happening behind the scenes. First, you need a constant flow of data, satellites, sensors, and models, and you need to make sure this data is up to date and reliable. At the same time, cloud platforms make the results accessible through dashboards, applications, so users can easily interact with the information. Finally, everything needs to be connected and monitored, so all components work together smoothly and continuously. So in the end, a digital twin is not just a model. It's a system that is constantly running, updating, and staying aligned with reality. When we talk about digital twins supporting real decisions, security, stability, and trust are really key. A digital twin is constantly updated with data coming from different sources, satellites, sensors, models. So, first of all, you need to make sure that this data is reliable, checked, and that you always know where it comes from. Then, all these different systems need to work well together. They need to talk to each other smoothly, otherwise the whole system becomes inconsistent. That's why we rely on strong infrastructure and continuous monitoring to make sure everything keeps running properly.
Anyway, if Megi's work ensures that digital twin function as a system, the scientific heart of that system lies in the models themselves. To dive deep into the whole different area, we spoke with another guest, Salvatore Causio.
My name is Salvatore Causio. I'm a coastal ocean modeler.
As a coastal ocean modeler at CMCC, Salvatore works on wave dynamics, extreme events, and high-resolution coastal simulations.
A digital twin allows us to simulate what-if scenario, exploring the potential impact of extreme events before they occur. For example, in case of an approaching storm, we can test different conditions, for instance, changing storm intensity, trajectory, duration, and we could immediately evaluate how those changes affect coastal area. This means that we can identify the main hazards associated with extreme events such as flooding, wave overtopping, erosion, and so on, but also understanding which area are the most exposed under different scenarios. Once we understood the risk, we can test protection and adaptation strategies. These are simple but powerful examples of what digital twin means for coastal management. Not only predicting what will happen, but understanding why, exploring alternatives and supporting better decisions to reduce risk and improve resilience.
His research also explores the integration of artificial intelligence with numerical models. But how does combining AI with traditional models improve our ability to anticipate coastal hazards?
The use of artificial intelligence in ocean and coastal modeling is quite recent, but it is already showing very promising results. In simple terms, AI learns patterns from large amount of data. This is why we call simply these approaches data-driven. Instead of solving every physical processes to equation, AI recognizes patterns and makes prediction much faster. And this speed is very important if you think about early warning system, for instance.
In the end, we need Giovanni Coppini's knowledge once again. It's time to understand how tools like the digital twin of the ocean can actually support real-world decisions, for example in coastal planning, risk management, or emergency response.
So first of all, the digital twin allows us to support coastal planning, to test future scenario before choice is made. And if you can trust the digital twin, then you can simplify your decision making more accurate. And then you can understand how much these infrastructure are exposed to flooding, or best option, how to set up a nature-based solution to protect the wetland or coastal area and infrastructure. So basically we can provide a real-time forecast, but also in the same context scenario simulation. So you can anticipate coastal flooding or support evacuation decision, but as well you can estimate the transport of the oil at sea, and then you can support the Coast Guard and the port authorities, the civil protection to prepare in advance.
Resilience is so relevant that technology alone cannot create it. Its value depends on who can access it and how it is used. One of the central challenges of digital innovation is ensuring that advanced tools do not remain closed in research centers, but become usable by communities, institutions, and decision makers. We asked Giovanni how digital twin can be accessible for Global South countries.
The digital twin, it's a scientific and technological component, which I like very much. But the part I like the best to make them really accessible and useful for people is when you develop them together in a partnership way. So the partnership is essential because it connects the scientific excellence with the real societal needs. This helps a lot to translate complex scientific tool into a shared resources for coastal resilience. And then digital twins are not just a technological achievement, not even only a scientific achievement, but they are a platform for dialogue between science, policy, and society.
This is where partnerships become essential, connecting scientific excellence with real societal needs. Within the UN Ocean Decade, Centers like the DCC-CR exist precisely to create these connections. By working with strategic partners such as CMCC, the DCC-CR helps translate complex scientific tools into shared resources for coastal resilience. Digital twins are not just technological achievements. They are platforms for dialogue between science, policy, and society. If this episode caught your curiosity about how digital twins work, there's a simple way to explore the science behind. In the episode description, you'll find a link to the CMCC forecasting systems. Through these tools, you can explore surface currents, sea level, wave height, sea temperature, and many other ocean variables. You can move across time, compare forecasts, and see how conditions evolve day by day. Visit the CMCC forecasting system through the link in the description and see how dynamic our ocean really is. Until next time, protect and respect our coastal ocean. Green Tides is a podcast by DCC-CR, Decade Collaborative Center for Coastal Resilience, produced by Podstar. Narrator Federica Orsi. Writing Lorenzo Molino. Sound design Antonio Mezzadra. Graphics Laura Fracasso. Producer Esther Memeo. Special thanks to CMCC, Euro-Mediterranean Center for Climate Change, Herion and Deltares.